How's it going, everyone? I recently made a video about the 2025 Eurovision results and how the judges and the public disagreed on many things. And one of the comments to that video really stood out to me, which suggested an alternate way of combining the jury and public scores for the songs in Eurovision. And this alternate calculation method has implications not just for Eurovision, but for all competitions where a jury score and a public score are combined, and has some very interesting philosophical implications as well, and changes the rankings of the Eurovision songs, and we will get to all of that. To those unfamiliar with Eurovision, it is a song contest where singers from different countries perform at a concert, and each song receives a score given by judges and a score given by the public. And the scores are added together to create a total score, and based on the total score, there's a first place winner, second place winner, third place, and so on. The diagram you see in front of you is the scores plotted, where on the vertical axis we have the jury score by the judges, and on the horizontal axis we have the score granted by the public. And these two scores are just added up for the total. Well, the alternate method suggested is as follows. Rather than the total score being equal to the jury score plus the public score, the suggestion is to have the total score, an alternate total score, equal to the jury score squared plus the public score squared and the square root of all of that. Now, some of you might recognize this as Pythagorean's theorem. So if you have a right angle triangle, and the length of the base is the public's score, and the height of the triangle is the jury score, well, the way this total score is calculated now, it would just be the total length of this path. The alternate method shown here would have the total score being the length of the hypotenuse that this right angle triangle forms. Now, how would that look on our chart? See, the current method has the total score for a country equal to, geometrically, the distance from a data point. Let's take Austria, for example here, right? So right now, Austria's total score, based on the current system, would be equal to the distance from the jury score axis, shown here, plus the distance from the horizontal public score axis, shown here. Adding the lengths of these two paths would give you the total score for Austria. But the alternate method would actually have the total score being the distance from the origin, the bottom left-hand corner, the distance from that origin to a data point. And calculating a total score in this manner actually would change the ranking of which country places where, and it even considers the scores with a different philosophy. And we will show that ranking, and we will get into that philosophy as well. So let's get into all of that. When we look at these two equations, we can actually create what are called level lines or level curves on the chart that we saw previously. And these are lines or curves along which the total score would be the same for countries that fall onto those lines. For example, with the current system where the total score is just adding up the public score and the jury score, the level lines would look like this. These diagonal lines with a slope of -1. The bottom line you see here, every country that falls on this line has a score of approximately 50. The next line upwards, every country that falls along this line has a score of approximately 100. Next line, every country along that line has a score of approximately 150. Next line, 200. Next line, 250, and so on. From this diagram, we can see how countries would place. Austria is clearly in the lead with a score above 400. And then we see a gap between Austria and the runners-up, and then we see the runners-up, Israel, Estonia, Sweden, with a score of approximately 350. Then we see another gap, and then we have a large group of countries with scores approximately between 150 and 250. That's this large cluster here. Then we see another gap, and then the remaining countries have scores below 100. But if we apply the alternate system, where a country's score is the distance on a plot like this from the origin to the actual data point representing the country, and that is what you would get if you were to define a total score based on Pythagorean theorem, as shown right here, well then your level curves look as follows. So each curve here is actually a quarter of a circle. It looks a little bit stretched out because the chart itself is stretched out here in the image, but these are quarters of a circle, and the distance from the origin to different points on the same curve is the same distance. So the lowest curve here, all the countries that place on this curve would have a total score of approximately 50. The next curve upward, all the countries on this curve would have a total score of approximately 100. Next curve upward, all the countries falling on this curve would have a score of 150. Then 200, then 250, then 300 for countries falling along the largest curve here, and so on. Now, this would change the ranking somewhat, and we'll see the specifics, but even visually you can tell already. So Austria is still in the lead with a score above 300. And you can see the alternate total scores right here, by the way, if you're interested. And then below Austria, we have the same runners up with a score of around 300 with Israel, Estonia, and then Sweden just below 250. And then things get a little bit different. For example, look at where Switzerland places in this new method. Switzerland has a score of above 200, getting 5th place. It scores above France, Italy, Greece, Ukraine, Albania. But in the method used right now, Switzerland actually scores below Italy. Italy gets 5th place, and Switzerland is around the same kind of score as France, Greece, Ukraine, and Albania. See, what the current method does, it actually benefits countries that are on this main diagonal of where the audience and the jury agree. If you saw the previous video, you'll be familiar with this image here, where the yellow bar represents regions where if a point is in that region, it means the jury and the public pretty much agree on the score. See, the current system benefits countries that fall within that region. For example, Italy is pretty close to that region, and it's getting 5th place right now, scoring above Switzerland, France, Greece, Ukraine, Albania. But in the alternate system, countries that are more on the edge of the graph are actually not as punished. Now, let's look at the total scores for two systems and compare what's going on. So, here we have the current system being used, and here we have this alternate system based on Pythagorean theorem. Here I'm calling the total score the radius because it is the radius of these quarter circles that we see here. So the top four actually remain the same and in the same order: Austria, Israel, Estonia, Sweden. And that's always nice to see, right? If changing the scoring system results in the same countries on top and the same ranking between them, that's a good sign, right? If changing the scoring system would result in different countries on top or a different order, well then that kind of is not too comfortable. Now, after the top four, things really start to get shuffled. Look at all this shuffling right here. So the red arrows show cases where a country dropped in rank, and the green arrows show where a country increased its rank. So Italy drops from 5th place to 7th, and that's because of something that happens with other countries. Greece, this is a big change, right? Drops from 6th to 10th, and we are about to see why. France goes from 7th to 5th place, but here is the big change. Switzerland from 10th all the way up to 5th. That is the biggest change that we see. These are the level line and level curve for Switzerland. See, on the current system, look at the level line. Switzerland is below France, Italy, Greece, Ukraine, Albania. Getting 0 points from the public, Switzerland scores 10th place. But when we look at the level curve that goes through Switzerland, it actually goes above France, Italy, Greece, Ukraine, and Albania, pushing it all the way up to 5th place. See, as mentioned before, this alternate system based on Pythagorean theorem, or based on the distance from the origin to a data point, however you prefer to think about it, it's not as punishing for countries that got a very low score from either the jury or the public, but a high score from the other one, right? So in places where the jury and the public strongly disagree, this alternate system does not punish countries for that strong disagreement, whereas the current system actually favors countries for which the jury and the public agree. So we see this big change for Switzerland. Now, because Switzerland moves up so much and France moves up a bit, well, that's going to force Italy down 2 slots because they both end up ahead of Italy. So Albania stays the same, Ukraine stays the same, and we do see Greece drop below as well. See, Greece is in the middle, in the region where the jury and the public agree. They benefit from the current system. If you change to the new system, Greece actually ends up on a curve. If you imagine one that goes through Greece, that would actually be below Ukraine, Albania, Italy, France. Moving on, the remaining changes are not as drastic. We see Finland go from 11th to 13th, Netherlands stays the same, Latvia goes from 13th to 14th, Poland jumps up from 14th to 11th, a noteworthy jump. And with Poland also, we see the fact that it's close to one of the axes here, which is kind of punished in the current system. And Germany stays the same at 15th, Lithuania 16th to 18th, Malta stays the same, Norway 18th to 19th, United Kingdom 19th to 16th. Similar situation as Poland. United Kingdom is way on the edge here. So that bumps it up if it's using this alternate system. And then we have Armenia in the same place, and then we have the countries at the bottom here. A little bit of change here, not too much. Portugal goes from 21st to 22nd, Luxembourg from 22nd to 23rd, Denmark 23rd to 21st. We see Spain and Iceland switch spots, with Spain going from 24th to 25th, and Iceland from 25th to 24th. And then we have San Marino remaining at 26th. So the question then becomes, well, which of these systems is better? Now, I could do a whole other lecture on how different geometrical approaches correspond to different philosophical interpretations of the data, but in the interest of time, I'll just give you the final answer. If you believe that the jury and the public are measuring the same thing when placing their scores, and we're just not sure which one's correct, so we can average the two, well then the current system, where the jury and public scores are added, is the correct system. If you were to average the jury and public scores, you would get the exact same ranking as if you were to add them up. The difference between averaging the two versus adding them up is just you would take every total score and divide it by 2. The ranking remains exactly the same. But if you believe that the jury and the public are actually measuring 2 different things, and we need to take those measurements of 2 different properties and somehow combine them for a total score, well then this system here would actually be the correct one. So the question is, are jury and public measuring the same thing, or different things? Well, I believe they're actually measuring different things. And here's why. If the jury is measuring the same thing as the public when placing its scores, well then why do we even need a jury? What's the point of judges? Why should their opinion count for more than the opinion of someone just voting online? And the answer is because we believe that the judges are trained to notice something in the performance which the public is not trained to notice. Okay, well that means that the jury are measuring this property that they are trained to notice, whereas the public is measuring something other than that property. Well, that means they're measuring different things, which makes this system the more correct one. And another sign pointing towards this is the fact that not just for song competitions, but in many artistic competitions where there is the public and there are the jury, a performance, a presentation can actually be strategically designed to either please the jury or to please the public, which again points to the fact that the jury and the public are actually measuring different things. Now here's the thing. Even if using this system based on Pythagorean theorem is technically the correct system to use, it does not mean that it is the correct system to use for Eurovision. And here's why. At the end of the day, Eurovision is a show put on to entertain the public. And most of the public has not gone through the mathematics that we have discussed in this video. They're just here to see a show and listen to some good music. And they can understand taking a jury score and adding it to the public score and getting the total score. But if you start telling them about Pythagorean theorem and the radius of a circle and squaring the scores and adding them and square roots and the hypotenuse, they might start thinking, well, why all this complex mathematics? Why can't we just add the jury score and the public score? Especially if the complex mathematics results in their favorite song being ranked not as high, well then they might think, well, that kind of doesn't seem right. Okay, so for entertainment purposes, the simpler method of just adding the jury and public score may actually be the correct thing to do. And so we end up with this interesting balancing act, this trade-off between accuracy and entertainment. And this trade-off is seen not only in song competitions, but in so many other places. For example, there were no dragons in medieval times, but medieval fantasy is a very popular genre, and that's okay. If some presentation decides to put more focus on the entertainment value rather than the accuracy of the information that it provides, that's okay as long as the audience are aware of that. Where problems occur is when people are so entertained that they start to consider the possibility that maybe there were dragons in medieval times. So, some people are entertained by accuracy, specifically because it is accurate information. That is what they came to see. But other times, people are just there for the entertainment. So if your audience is there for the accuracy, well then focusing on accuracy would actually work out quite well because the accuracy is entertaining. If your audience is there just for the entertainment, well, focusing on the entertainment might make more sense, as long as the audience are aware that accuracy isn't the goal here. But they might not always be aware. And this creates an interesting situation where perhaps when we observe people being very entertained by some presentation, maybe we should ask ourselves, the information in this presentation, is it accurate? Or is there a trade-off going on? So, until next time, enjoy.